And question number 4 is all about recognizing differences of squares. So in grade 10, often our differences of squares looked like this. You had something squared, usually it was x, and then you had minus a number, like 25, that was a perfect square. And you could factor that by doing x plus 5, x minus 5. And we've learned that these are called conjugates when you have a binomial with the same numbers and just the middle number, just the middle sign has changed from plus or minus. This is on page 175. So then for A, if we recognize something as a difference of squares, in other words, there's a difference in between, and both the first term and the last term are squared, it's just going to be A and A, B and B. One of them will be plus, one of them will be minus. And if you multiply this out, you'll see that your outside and inside terms cancel each other out, leaving you with just A squared minus B squared. Now in B, technically, we could do substitution and say, I'll let A equal this inside 1 and let B equal this inside 1, and then I would just be left with A squared minus B squared. However, if you do notice, it's still the same format. We have something squared minus something squared. So in my first one, and I'll put it in brackets, I would have 3x plus 4 and 3x plus 4. And I would have 2y minus 1 and 2y minus 1. And one of them will be plus, and one of them will be minus. Now, in those big set of brackets, we could combine some like terms. So this first set of brackets, I have 3x plus 2y, and then the 4 minus 1 just becomes plus 3. And in my second bracket, I have 3x minus 2y, and 4 minus a negative 1 would become plus 5. And we could simplify this. But again, we're recognizing it as a perfect difference of squares. We run into a little bit of a problem in the last one. Everything seems to be working out nice because I have a difference in between. And I have 2x minus 3 squared and y minus 4 squared. So those are both perfect squares. However, the problem happens with the numbers in front. Is 27 a perfect square? No. How about 75? No. But what I do notice is that I have two terms. I'm going to put a square around both of those terms in purple. I have the one purple term minus the other purple term. And in both of those purple terms, if I look at the numbers, they have a common factor between 75 and 27. What number divides both 27 and 75 other than 1? 3. Excellent. So I could pull out a 3, and then I can put a big square bracket and say, well, what would I have left? If I pull a 3 out of the first purple term, I would be left with 9, 2x minus 3 all squared. Minus, and if I pull a 3 out of the second one, I'd be left with 25. Y minus 4 all squared. And now that I've factored out that 3, now I have, again, I'll put them in a purple box, one term minus a second term. But the nice thing now is this is a perfect square, and this is a perfect square, because 3 times 3 is 9, and 5 times 5 is 25, and of course this is squared and that is squared. So I can, again, write that I have 3 first one, if I square root it, right? Because if I multiply 3 times 3, I would get 9, and 2x minus 3 times 2x minus 3 would give me 2x minus 3 squared. My second term would have to be 5y minus 4 and 5 minus y minus 4, because 5 times 5 is 25, and y minus 4 times y minus 4 would be y minus 4 squared. And since this is the difference of squared, one of them will be plus, one of them will be minus. And then from here, we could multiply this through and combine our like terms. You see that you would have 6x and 5y. And my numbers, I'd have negative 9 minus 20, negative 29. And the last one, 3 times 2x, it'll be 6x. And I'll have minus 5y. And I'll have negative 9 plus 20 plus 11. So these are still differences of squares, but we're getting a little bit abstract with them because we're making our squares bigger things. Okay? If you recognize the overall pattern, then having bigger things, like the two purple boxes, are both perfect squares, makes the question the same as when it was x squared minus 25, just with bigger numbers. The idea, though, still stays the same. All right, some questions for practice. You can circle 12, 13, and 14.